Okay, we have to talk about polar form, exponential form, and the Cartesian form. I'll be talking about this Cartesian form first of all because this is the form that you people are already familiar with. Okay, do you know when you're dealing with the coordinate uh, geometry, so you use this x-axis and the y-axis. So what do we call this? This grid, this has a special name. What is this? Called? Hmm? If this is the x-axis and this is the y-axis. So what do we call this two-dimensional plane? Hmm? This is called a Cartesian plane. Okay, Cartesian uncle jo the, he was, I think he was a British mathematician, and the British queen at that time, I think that was around like a few hundred years ago ki baat hai. So the British queen wanted to learn mathematics from him, and this it was very cold those days, so he had to go all the way from his house to the palace to teach her. So he got that pneumonia. Okay, so he was like he died in a very young age. Okay, so he was in his bed. He was sick. So he saw a spider on the ceiling in front of him. Now he wanted to tell someone that where is that spider located exactly. So then he thought that how can he give the exact location of that spider. So there and then you see this Cartesian plane. He discovered this Cartesian plane. Okay, so that is because of that spider. So like you see, for example, if this pankha is the center of the ceiling and he found the spider over here, so he could tell someone that, you know, let's say maybe uh, these many feet to the right and these many feet to the left, you can reach that spider. Okay, so anything which has the x coordinates, the y coordinates, the x and the y, any equation that has x and y in it, that is called the Cartesian equation. For example, if you have y is equal to 2x plus 3, so that is a Cartesian equation. Okay, now if we have a complex number which is just 2 plus 3 iota, so this complex number is written in Cartesian form. In Cartesian form. Okay, this is written in Cartesian form. Now we have to see that what is its polar form. Now this polar form is basically, this is taken from a circle. Like if you have a relationship between uh, the variables through which you can find the location of any point on a circle, so that is going to be polar. Okay, so let me show you how this works. Again, I think I have told you when we started trigonometry. Do you remember? I told you that if suppose there is a point, it is a point P which is x comma y, and this has rotated theta degrees. This is the radius over here. Okay, so this is your y and this is your x. Now, can I say this y is equal to r sine theta, and then this x is going to be r cos theta. Are you familiar with this, bacho? Hmm?
Yes,
Yes?
sir.
Hannah? So if you know the radius, you know this angle theta degrees over here, you can tell the y coordinate, you can tell the x coordinate. Now imagine if this is the real axis here. Okay, this is the real axis and this one is the imaginary axis. Okay, then instead of this x plus y, I can say that here is a complex number. This p is representing a complex number, which is basically x plus iota y, which is x plus iota y. Now, can I say that this p can also be written as, please, you have to see this. Can we say that this P can be written as R cos theta plus iota R sine theta? Yes or no? Come on. Hmm? Because X refers to the real part and y refers to the imaginary part. So this x is r cos theta and this y is r sine theta. So if you take r as common, so this becomes r cos theta plus iota sine theta. Now this is the polar form of any given complex number. Okay, and here this r, now suppose if that this was a complex number z over here, okay, then r is going to be the modulus of z and theta is going to be the argument of z. And if you write the same thing in the form, let's say if you write in this form, r e raised to power iota theta, where r is the same modulus of z and theta is the same argument of z. Now, this is called the exponential form of a complex number. We shall not be going into the very details of this r e raised by iota theta because this is beyond the scope of our syllabus, but we can go into the details of this. I have given you all the reasons that how this complex number, which was x plus iota y, that has been written as r into cos theta plus iota sine theta. Now imagine you have a complex number. Let's say there is a complex number. Suppose there is a complex number which is 5, and this is cos pi by 3 plus iota sine pi by 3. Now we want to convert this complex number back into the Cartesian form because this is right now written in the polar form, okay? So we must know that cos pi by 3 is half and sine pi by 3 is under root 3 over 2. So this is going to give us 5 over 2 plus 5 under root 3 over 2 iota. You can write iota before or after this, okay? So this is the Cartesian form of the complex number, which was this, okay? Now, if you want to check this, now this complex numbers modulus should be 5. Let's check that. Now, suppose this is z, okay? This is z. Now, how do you find the modulus of z? You have to, like, 5 over 2 square is 25 over 4, and 5 under root 3 over 2 square is going to be 75 over 4, okay? So that gives us 100 over 4. That is under root 25. So that is 5. You see that this 5 matches with this 5. Now, suppose you want to check that if its argument is really pi by 3. So you will do that, like, you will find tan inverse of 5 under root 3 over 2 over 5 over 2. So 2 is cancelled with 2, 5 with the 5, and tan inverse of under root 3, you know that that is pi by 3. So you can always switch between the Cartesian form and the polar form, believing that this r is the modulus and this theta over here is the argument of our complex number. Okay, let me give you some questions here that you can try. So let's try to write its polar form quickly. By the way, when you write it in this form, r cos theta plus iota sine theta, your theta can be both in radians or in degrees. This is up to you. If you want to keep that in degrees, go ahead. You want to keep that in radians, choice is yours, okay? Well, let's find this modulus quickly. The modulus is going to be 13. We know that 5 square plus 12 square is going to give us 13. Now, for the argument over here, this is 5 over here, and here it is minus 12. So the complex number is going to be somewhere over here. Okay. Now, someone quickly tell me what is tan inverse of 12 over 5. You can give your answer in degrees. Okay. Come on, tell me quickly what is this tan inverse of 12 over 5?
The minus 67 degrees.
67.67.3.
338.
Okay, so this is 67.4 degrees. So this is going to be 13. Theta is minus 67.4 degrees. So I will write this as quickly 13 cos 67.4 minus iota sine 67.4. Why did I write minus and why didn't I use that minus over here? Let me, there's less than 1 minute.